Welcome everyone to our webinar Wednesday. Today's XPlanar, the next evolution of linear transport. My name is Jeff Johnson. I'm the mechatronics product manager for Beckhoff in the US. Been with Beckhoff a little bit over 16 years. I've got my 43rd year of industrial automation. I've taken over the product management role for XTS and XPlanar a little over 6 years ago. Prior to that, I was application engineer covering mainly Wisconsin. So today we're going to talk about XPlanar. So little teaser video here. So XPlanar, it's a transport system, but it's a revolutionary approach. So there's no fixed mechanics. It's free-floating magnetic movers. So you get free 6 degrees of freedom. It's contactless. It's no noise, no friction, no wear. So it's a whole different approach. As we go through the presentation today, we're going to show a lot of examples on how you can utilize this technology. As you can see from the videos here, you have complete freedom of movement with the movers. We can even rotate, so you can actually rotate 360 degrees while running. So today's seminar, we'll do a short introduction, little overview. I'll give you a timeline of the development, then what makes up a system. Then we'll do a lot of application videos and talk about benefits, how the different tile sizes can help reduce the footprint. Then we'll have a guest speaker, Joe Caccini from Automation Nth, will talk about their projects. A few more videos, give you a little preview of what's coming up next for new features, and then we'll have key benefits and points, and then we'll end up with a question and answer session. So with that, let's go into a timeline here. So back in 2014, we did our very first, think of it as concept. So we had circuit board and some magnetic slides, as our first test. And then in 2015, we actually started the development of what you see as XPlanar today. In 2017, we had what we consider the first internal beta running with first flight of movers lifting off. In 2018, we showed it at the SPS show in Nuremberg for the first, product introduction. In 2019, we started delivering starter kits. The first one was delivered to Plasma Trade, a company in Germany. Towards the end of 2019, we did a few starter kits in the US. And then in 2020, we did the official release. We started shipping, 1 to 2 starter kits per week. Since then, in 2022 and 2023, we introduced some new movers. We introduced our stainless mover to the marketplace. At the end of last year, we introduced a new tile size, the APM42. It's a 320 by 320 tile. And then later this year, we'll be introducing some rectangular movers, and then also a multi-PC control from a software standpoint. So what makes up XPlanar? So when you look at it, there's really 4 base components. We start with our TwinCat software, so we do all of our development, all of our programming, configuration, everything's done in TwinCat. We run that on one of our industrial PCs or embedded controls, and then we talk EtherCAT G from a field bus to the tile. The tile has all the power electronics, the feedback sensors, and everything. And then we have the movers. The movers themselves are passive; they just have permanent magnets. So again, 4 base components. You have your software, your controller, the field bus, and then the tiles and the movers. So very clean from a software standpoint and very clean mechanically. So a little video here. The videos are probably a little bit blurry for you because we're showing some really high dynamic motion here on one of our 2 tile starter kits. As you can see here, we get the free XY motion with the movers. And we'll have a side view coming up so we can see rotation, so you can rotate while moving. Showing the lift and the tilt capabilities of the movers. So from a motion standpoint, you have the full 6 degrees of motion. You have the free XY. We can 0 to 5 millimeters up and down. We can tilt an X and Y, and then we can also rotate. So some capabilities. With the new tiles, we can get up to 3 meters per second. The APM, the APM 4230 tiles, there we're limited to 2 meters per second. We can lift 0 to 5 millimeters, 360-degree rotation. You can move about plus or minus 5 degrees while moving. Right now, we are working on a feature where we can actually will rotate while moving, but that feature isn't released yet. The layout can be pretty much any layout. When you look at it, we talk about tiles, the base of it is a tile, so think of it as a, we're putting down tiles in a floor. You just line up the tiles so that they're all in the same XY orientation, and you can lay them out in any type of format. So it can be lanes, rings, rectangles, whatever format you want. You can have multiple movers, multiple different size movers in a system. Payloads all up to 10 pounds per mover. You can tilt plus or minus 5 degrees, or tilt 5 degrees in X and Y. And then we also have a mover identification. So the mover identification allows you, us on power up, since it's an absolute system, the first tile you put down, that's your 0, 0, and X and Y. And then wherever on power up, wherever the mover is, we can identify where it is from an absolute standpoint. And we also have a mover ID, so you can uniquely identify each movers. So it gives you that complete, track and trace even through power cycles. From a benefit standpoint, we'll talk a lot of these as we go through the videos, but we can minimize the machine footprint. It's a very compact design. You have, important part is variable station and mover pitch. So on a traditional system, let's say an indexing conveyor or rotary indexer, your station pitch is always defined by whatever your largest station is, and all the movers index at the same time. So with XPlanar, we have this free or individual motion of each of the movers. So movers can be moving while some are stationary during your process. So that really opens up the lot for your design to minimize the footprint, and because you're not fixed with a fixed station pitch. Innovative machine concepts, we can shorten your market time. We can simulate and visualize the system ahead of time. Truly lot size one. Each mover can be doing a totally different path than the other ones. And then there's a lot of application industry specific advantages we'll point out. So let's go look at an application. So this is actually in our own manufacturing facility. So we have like over 4,000 different IO terminals. So on this line here, you can see the robots are loading terminals onto movers. And each of those movers, every mover could be a different IO terminal. So it's truly lot size one. So we could be doing different movers or different products on each mover. So then the movers get delivered to one of 12 programming stations. So we'll flash the firmware, and then we'll deliver to one of 16 test stations to test the hardware. In the system here, we've got 3 lanes of traffic. So we have like a left-hand side, a right-hand side going to the programming and the test stations. And then the middle, we leave that open for return. So the nice thing here is the movers can take, the shortest path to the next station. We utilize the ability to be able to lift up. We drop the terminal into the unit. The cassette pulls it in. It runs its test. And then when it's done, we lift it up and we pick it and go from there. So this is a really good use case. The system is available if you want to see a running system. We invite customers. You can travel to our facilities over in Ferrell, Germany, and actually see this production line running. We talk about simulation shortening it. So here's just a little graphical view of the system. So you can see the load, unload on the left, the programming station, the test stations, and the different tracks that we've programmed to manage the flow of the movers. But then from a simulation standpoint, this is showing the live view. So you can actually run this on your laptop or one of your target computers. And that way you can look at the flow of things, determine, are there bottlenecks in the system? Is this the most efficient layout? And we've been doing lots of simulations with customers. So usually if you come to us with an application, we'll talk about it. You have a basic design. Maybe we'll rearrange things. But when we do simulations, and then from simulation, a lot of times we start shifting things around, changing layouts, and to come up with the more, cost-effective or more, the best throughput of the system. And we can do this, early on in the design phase, which is good. So from our system that we did, we increased our productivity because we're very efficient bringing the terminals from station to station. We were able to visualize this and design it ahead of time, so it was shortened up our own design cycle, and it is a lot size one. It gives us that maximum product flexibility. Another application here, one of the early adopters was Provisor. They make slicing machines for the food industry, mainly like sausage and cheese. So in this concept here, what they're doing is they're using the XPlanar as a buffer system. So as you'll see in the video, as the slices of the cheese come down, what we're doing is we're providing stacks of cheese to a flow wrapper downstream. And flow wrappers like to run at constant speed. They can speed up and slow down, but you don't want to stop them. So when you run out of, say, product, you have to change the log of cheese or sausage. You have to have enough slices in the buffer to keep feeding the flow wrapper. So that was the whole concept here. Typically, it's done by a long series of conveyors, so that buffer section gets quite large because you've got to start keeping a lot of product in the buffer. So here we can see the slicing step, bringing out the little stacks of cheese. As they come down the conveyor, then the movers will synchronize to the conveyor to pick up the slices of cheese. Then we'll create the buffers. So it's 2 lanes feeding 1 lane going out, and then we can synchronize the other mover to the exit conveyor. So it gives you a lot of flexibility. So this is, we build up the buffer here. There you can see as we're synchronizing at the end. So when you think about it here, you've got these 2 lanes coming in. Now you'd have to have a lot of conveyor to actually merge the 2 lanes together and then keep it feeding. So here's a little animation showing it. Creating the buffer. Now we run out of cheese. So now we're using up the buffer space, and then we start producing more slices and start refilling the buffer. So again, one of the big advantages here was a reduced footprint for the multi-lane buffering. We reduced the overall footprint for that. And then from an application specific thing, we synchronize, so we can synchronize the mover to both the loading and unloading conveyors, and you can have the continuous production, while we're reloading. So reduced footprint and continuously running the machine were 2 big benefits. So how can we reduce the footprint or design the most cost-effective solution? So when we first introduced this back in 2020, we had our 240 by 240 tile, or about 9.45 inches square, and we had the various movers. So we have the 113 millimeter mover, the 155, and then we had the 235 millimeters. So payloads anywhere from 1.3 pounds, 4 pounds, up to 10 pounds. And then we introduced the 5-inch of the 127 millimeter, 2.2 pounds. So we have the different mover sizes. And with the last year, or at the end of last year, we introduced the new APS 4244 tile, which is 320 millimeters square, and also a half tile. So now with these half tiles, it's going to give us even a more efficient layout. One quick note, the tiles themselves here are IP40, but you can cover them with, say, a 0.5 millimeter sheet of stainless for a clean hygienic system. You can put plastic over the top to protect it, glass. So any non-ferrous surface you can put over. Typically we say to keep it to about a 0.5 millimeter thickness, because that does eat into your flying height. But with this 2 different tile sizes now, it gives us a lot of flexibility. So we have the AP4230, which is the top and the bottom rows here. So with the middle size mover, the APM 4330, that seemed to be the workhorse for that. A lot of applications fell into that range, but you'd have to be 2 tiles wide with it to get 2 lanes of traffic. If you're using the small mover, like in the bottom picture here, there you could use 1 tile wide to get bidirectional traffic flow. What we wanted was a more efficient, cost-effective solution for that middle-sized mover. So with the AP4244, now we can get 2 lanes of traffic being 1 tile wide. When we use the half tile, then we can use a single lane. So on the right here, you can see we've got the the full-size tile and then the half-size tile. So now you can basically design your footprint or your layout to be the maximum for it. If I'm just using the small movers, then the 240 by 240 tile would be the most cost effective. If I'm using the middle size or the large size movers, then it'd be more cost effective to go with 320 by 320 tile. So what that allows you to do is then maximize your layouts. So when you look at the IO production machine on the top picture here, when we designed this system, we just had the 240 by 240 tile. Today, if we could redo that manufacturing line with the new tiles and the half tiles, we basically reduce the footprint by 55%, which then it comes out to about a 54% cost savings. What drives the cost of a system is the number of tiles in a system, because that's where all the power and electronics are. The movers themselves are passive. So with these two tile designs, now we can pick and choose which would be the most cost effective for your solution. So with that, let's go take a look at another application. So this is Senegon. This was a machine they designed, and they showed it at Interpack. I think last year is when they were showing it. It's similar concept. So they've got two lanes of products coming in, and they're feeding a downstream cartoner. So they're taking advantage of the fact that you can have the movers can synchronize to the conveyors using vision to do inspection on the products. Here, so they grab the product and they deliver it downstream, showing some of the HMI there. Again, flexibility here so they can handle different size products, different size packages, depending upon what they're running today. Again, software format changeovers versus mechanical changeovers. Completely tightly integrated system. The entire system is controlled by Beckhoff hardware, drives, and motors, so we can tightly integrate everything together. So again, multi-lane buffering reduces the overall length of the system. They can synchronize the loading, unloading, and lot size one. They can run multiple products. Next video here, this was a plasma treat. So like I said, in the timeline, they were one of the first beta site or starter kit users, and they do plasma treating. So they have different nozzles for doing, the first step is to coat the product, and then they do a functional layer after it. So the typical machine, they would have had 6-axis robots controlling each nozzle, and then the part would just index in front of each nozzle, and then the robot at that station would do the application. So taking advantage of the free XYZ motion, 6 degrees to tilt even, it allows them to make a more compact machine. It simplifies the tooling. So instead of two 6-axis robots, there's simply just a Z axis to come out for the heads. So again, benefits here, we eliminate some robots for each nozzle, so we reduce footprint there. And then utilizing the application specific, that 6 degrees of freedom allows for very even coating across all surfaces, because we can tilt the product, and that as it comes in, to make sure that we get the corners and get everything good. So this little animation here, we're sort of showing how you can use XPlanar, like in a lab automation, or this could also be like different assemblies. So you look at a lot of traditional systems. You've got a conveyance system that delivers a product. A robot will load a part into a work cell, and then that work cell will do its whatever process it needs, and then load the product back onto the conveyor, and it exits down to the next station. So now, when you start designing your system around XPlanar, we can eliminate those robots for loading, unloading. We can bring the part directly into the work cell and then do the process. In the case here, we're doing liquid handling. Now the liquid handler, instead of being multi-axis, it's just a Z-axis coming down, and then we use the X and the Y for the mover. the animation here, we're sort of filling out the whole line, so you have different stations, different machines. You can see we're utilizing the fact that we can lift up and drop product into different test stations. And then as you build this around a process, you can easily expand it. You can always add more tiles, you can expand the system, and then you have to reconfigure the system for the new layout, but then you're off and running. This is showing an advantage here. You can have a different exit and entry point to each of the stations, so you can really maximize your throughput through a system and minimize your lab space or your manufacturing space. Another demo we showed at SLAS, this one here, we have two different instruments. There's a capper on the left and then a labeler, or it puts a cover over the well plate on the right. So utilizing the ability that we can go up to like 5 millimeters, we set the well plate into each instrument. We tell the instrument to close, it does its process. For the demo here, we were just showing it spinning around, doing a few things while we wait. Now we can come in, tell it to open up the cassettes, and we drive in, we lift the product, and then take it down to in case then we would take it down to the next process for it. This year at LCLAS, this is a company that we've worked with called LabSync. They're out in the San Diego area. And they actually took both that animation and a lot of these concepts and built an actual full cell here. So they're doing the liquid handling. So instead of handing the product off, we'll drive the movers under the cappers, drive them under the liquid handling. So they're taking full advantage of designing a very compact work cell, utilizing all the benefits of the XPlanar system. And see here, come down, take the cover off. On the right there, we're loading a product into the cartridge. We can see here they're actually tilting, and at this place, the reason they're tilting would be that station you're actually drawing the liquid out. So by tilting it, now that allows you to get like every last drop out of each of the different wells inside the plate. So it was a very good use. This showed really well. It was a very good use case of how you can apply and take advantage of all the features of the XPlanar. So again, from this system here, designing, they basically hit all difference. We eliminate robots for transferring parts at each station. Movers go directly between stations, so there's no long loops, very efficient transport. They were able to simulate this before building it to maximize or minimize design time. Lot size 1, each mover can go to different stations. So in a lot of different processes, you can skip processes if you need. The mover just bypasses those stations, and then they're able to use the tilt feature for tilting it and getting every drop out of the system. So with this lead in from Lab Automation, I want to introduce our guest speaker, Joe Cucini from Automation Nth. We've been working with them on a project over the last year. They do a lot in the life sciences and lab automation. So with that, I will turn it over to Joe.
My name's Joe Cucini. I'm a staff engineer at Automation NTH. I'm going to talk to you a little bit about the process that we went through with Beckhoff, but before, I'd like to give you a little bit of information about our company. We're an automation consulting company. We do custom automation. We build machines from scratch. We do equipment optimization, and we can also be hired to do software. We have 2 locations, one in Nashville, that's our headquarters, and one in San Diego. And our mission is to provide high quality automation equipment to enable the production of life-enhancing products. So we do a lot of work in the life sciences sector, but we also do work in other sectors as well. Our core values are customer-centric. We very much care about our customers' success. When you're successful, we're successful. We're very curious, and that leads to a lot of really ingenious solutions for customers. Sometimes we can be a little bit too curious, but we're a very curious group. Very collaborative. We work as one team, but also we collaborate with our customers quite a bit. We're committed to always doing the best job we can, and that comes out in pretty much everything we do, the way that we structure our software, but even down to the fit and finish of our machines. We always have a can-do, game on mentality. So for us, this is actually pretty fun stuff, and we're always caring and respectful amongst team members and with our customers as well. We're skilled in many things. Here's some highlights. We do vision-driven robotics, a lot of mechatronics. We do a lot of vision, PLC, and SCADA systems. And one thing that's there's a need for it now more and more is we do custom Part 11 compliant databases. So you need to store information for your parts or whatever it is you're doing on the machine. A lot of times there's a gap from the machine database to your system database, and we can make Part 11 compliant databases. And then we have the documentation to back that up, so it makes any type of validation process a lot easier for the customer. All right, so on to the Beckhoff stuff. We started looking at the Beckhoff as a solution for a project that we had, and so we had an apps team draw up some ideas on how they were going to do this, and I communicated with Beckhoff. You'll see in the back is Todd from Beckhoff, and they said, well, we'll program all these scenarios for you, which right now you're seeing a rotate, then the mover comes down in the Z and clamps. The mover has 6 axes that can all be turned on and off independently. So when we go down in the Z, it actually turns off the A and B tilt and the Z, and then it kind of clamps itself so that you can pull on the mover. This is showing a Z adjustment here. So Todd actually programmed all of this stuff for us offline. I showed up, we spent a day, and you can see him, he's over there on the PC, and I'm like, hey, can you do this? Can you make it do that? And he's actually making those changes for me live. Right here, we're trying to see how much we can actually tilt the mover and whether or not we can kind of rotate about the center of the mover or rotate about the left or right edge of the mover to kind of have it swing like a door. I think Todd was able to get that by adjusting the Z height while simultaneously adjusting the tilt. And so he was able to show us a bunch of these various things that we were told that could be done, but we wanted to actually see it. You can't see it in this video, but there's like a slew of like weights and things that Todd had produced, and I was like sticking like little weights onto the mover and seeing if it could do all this stuff while moving the weight around. And I was poking it with my finger, and I had like a pen, and I was jabbing into it. And you'll see in the video here, and you can see how cool Todd is remaining as I'm messing with his demonstration. This one we wanted to see whether or not we could tilt, move in the X and Y, and load a spring at the same time. So it was a really specific thing we were trying to accomplish. We didn't end up using this exact mechanical arrangement, but we did do something similar. So one of the things you can do with one of these movers, this is the small mover, is you can actually bring it up under a hook and then load or unload a spring. So you can load your part, and then you can use your spring to bias the part, which is something we did to great effect on this project. This is showing we're tilting, and then we're moving into the XY at a very specific speed, very specific rate, which Todd programmed for us. So this was our main evaluation. Could the XPlanar system actually do all the tasks that we wanted? We thought it could. So we moved on to stress testing. We wanted to use this as like an XY SCARA robot replacement, where we're going to move to all these random XY locations, Z up, Z down, and then move. And our customer had a lot of heat concerns, and so Todd accommodated us. The tiles actually have fans, and they can either have fans or not have fans. So he did testing with and without fans, and then there's also a water cooling option, and so he did a test with water cooling. These were all multi-day tests, and we were able to see how did it run at various takt times, velocities, accelerations, fans, no fans, water cooling, and then I was able to share that with my customer. The next thing the customer was worried about was whether or not it really could do 10 micron precision. So Todd spun this test up for us, and this ran for multiple days too. You can see that he's Zing up, but what you're not going to see is that we actually did multiple heights. We did with and without cooling. We did multiple times of the day. Pretty much anything you can think of, we moved that down to the corner of the mover. And then Todd was able to send me all that in basically an Excel file, and we were able to plot it for the customer and show them how accurate and precise the system was, which it was very accurate and precise, at least as good as what they list, actually a little bit better. Then, so we decided we want it. We moved on to a simulation phase. Here you can see on the right side is the movers are doing random XY moves, which are dispense locations that are generated from CAD files. and they're just lot size one, like Jeff was saying. You can just tell it to go to those XY locations, and it does. And then the left side's handling offload and onload. Todd actually programmed this for me. At this point, I have about the 8-hour trip and no programming into any of this. All the work was pretty much done for me by Beckhoff. So at this point, we've bought the system. They invite me to Denver, and we do training and snacks. And so headed out to Denver, spent a couple of days with those guys. They trained me up on how to use the system, gave me really good healthy snacks, coffee, really cool mountain views, provided me with lunch. All I had to do was pay for my plane tickets. That was well appreciated. Um, so now we have the problem that we just don't have enough time to program it right. We bought it. The parts are trickling in. Beckhoff has actually at this point provided me with a loaner piece of equipment, and I'm trying to spin up a simulation of my own. And they tell me about the special projects team, which they have a GitHub as well as a complete documentation, online documentation. And what this does is takes care of all the software that you would need for stations, mover arrived, and this type of logistics handling logic, which I've done a lot of maglev technologies in my career, and that can be a several month process to develop the framework for that. This was a complete drop in. I just dropped it in, utilized the existing code. The movers move along their paths. They end up at their stations. And then in the code, there's actually a place for you, the user, to do whatever you want, to go pretty much nuts. At which point you can disconnect the mover from the track, and you can do essentially make a robot program, right? It's a 6-axis robot. You can move in the X, Y, Z, A, B, and C. And so I want to talk to you a little bit about the path-based development. Moving in the X and Y is generally handled by paths. This you can do arched motion. You can do pretty much anything you want. You basically are drawing a track in on your table. They have a graphical tool for this, and it works just fine. For me, you'll see I have yellow and red fields, and we had some very specific guarding, and I had to use specific CAD data to essentially dodge it. And then there was a couple of operations where we were placing within, like plus or minus 30 microns, and we needed very specific camera placements. And so Todd and the people from Beckhoff provided me with basically this is how you would make your own Excel file to do uh, and how you would use it to generate code. So you don't have to do it this way, but as always, the Beckhoff gurus are there to help you. So they'll just, if you ask them, they'll tell you how it's done. They'll let you know all the caveats. This took me probably a week to do, and it was pretty invaluable for me. Anytime I made a change, I could hit the generate code button. I had like a list of stations and their names. I wanted them to be named a very specific way. Anytime I made a change to anything, I could hit the generate code button, and then I could just dump this directly into my program. Like I said, there's a graphical way of doing this, and there's some point and click ways of doing it. But for me, this was the way this was real valuable to me because we had a customer making changes to the way we did our system, and this kind of rapidized that development. We talked a little bit about the way that the system. So I'm going to show you a video of that now. This is a LinkedIn article. You can go look it up if you like, and there's a video that we filmed with Beckhoff. Our customer had a disk, and on the disk, they had essentially random XY locations. They couldn't tell us from disk to disk where those dispense locations would be. They just knew that they would have like less than 100 of them, and that there would be 48 unique dispenses. So what we did was we put 4 nozzles per tile, each being able to produce its own unique dispense of a product. And then we give it a set of CAD XY points and then the nozzle we wanted to go to. And using a little bit of basic math, we were able to offset and move any position on that disk to any nozzle that we want and then do a dispense. So that's pretty amazing. It really it solved the problem just right. But the big thing about it is in order to do this traditionally, like with a Scara robot, you would need at least 10 Scara robots, 11 Scara robots with 4 heads each, or you would need 44 Scara robots, each with 1 head each. So you guys can imagine how hard that would be, teaching points and so on and so forth. With this system, we actually bring the mover in, and we use the mover as a CMM, and we're able to teach the mover's position, and then we can offset from there. So it's really just one teach point and then offsets, which brings me into my next point, which is the Scara replacement, which is the way we pretty much use the system, although it gives you a lot of flexibility. This is a basic XY coordinate transform that Todd had given me. And this is what I use to basically do everything that I just talked about. It's just basic math. You teach a single location, then you just offset from there using x prime, y prime. Program it one time, it's all object oriented, and then you can basically distribute that to your various uh, stations. So you program once, and you have however many stations you need. This is a demo machine that we made outside of that bigger machine. It's using the exact same XPlanar code that I had on the other machine with like a few tiny modifications and slightly different XY values. The function's exactly the same. I brought the movers in. I used them as a CMM to teach that tip. Went to our mechanical designer, got the XY offsets. I had this machine going in about a day or two for the XPlanar from scratch, and about a week altogether with wiring and everything. And part of that was this 2 tiles that you see here is part of what's called a starter kit. And so we just built our machine around the starter kit. And then we also have some other standard products that we make on this machine. Uh, so you'll see that there's an orange top and a black top. One has 4 positions and one has 3 positions. And like I said, there's a sensor that's just saying, hey, it's the orange one. And then it just goes to a pre-programmed set of CAD coordinates. It's the black one. It goes to a set of set coordinates. You could drive that with a camera. You could drive it really with whatever you want. It's basically just a 6-axis robot table with each mover being independently controlled. So yeah, for scare robots replacement, you really can't get the density is at least 10 times as great as what you could get out of a robot. We created a little human interaction here, so it is possible to kind of clamp the mover and let people interact with it, which is fun at a trade show. This is the last thing I wanted to show you guys. One of my coworkers, while I was working on the trade show machine, was like, hey, can you show me whether or not this thing could do a dial? And he needed to pull on it, right? So what I did was I programmed up another station. I went into the section of the object-oriented code that allows me to do my own custom programming. I just joined it from the track. And I just said, hey, mover, I want you to spin 180. I want you to go whatever you've already gone 180 degrees plus 10. So it goes 190, 200, 210, 220, and then I want you to come down in the Z, clamp, and then you can't see it in the video, but then my coworker came and pushed on it, made sure that could hold the forces that he needed. And so this took me about a good 15 or 20 minutes to program once I already had it all set up. So overall, can't stress just the amount of flexibility that you have in the XPlanar systems, the amount of support that I got from the XPlanar and Beckhoff folks. I probably have over 500 emails between me and them and multiple video calls. So they're with you all the way. And I just can't say enough good things about them.
Thanks, Joe. For the presentation, it was a good summary of how we've worked together on this project. It was one of the more demanding ones from the high precision. You've got a lot going on there, so it was a really neat and fun application that we did. And we've done this with a lot of other customers too. So in Denver, we have our advanced applications group. So we have a lab there for doing a lot of testing, and we can also do testing in some of our other offices. But the office in Denver, we have like the most equipment that for these type tests, and that with from vision and cooling and everything. Just a second here. Okay, so with that, I'm going to keep going to my next slide here. So this video here is actually a video of a 2-tile demo with the new 320 by 320 tile. So here you can see we have the free XY. When we designed these new tiles, we increased the power to it, so we have more power for the movers. The rotation takes the most energy to rotate, through the magnetic fields. So here we're showing actually rotating while moving. While this feature it's still under development, so we're still developing it. We don't have hard specs on it yet as far as we know it's going to be reduced payloads and that for doing the rotation while moving and from precision accuracy, but it is a feature that we will be releasing later this year. A lot of questions we get sometimes about how to load, unload parts. So in this case here, we have a little demo of actually using two movers. So if you have a heavier payload, or in this case here, maybe you want to rotate, it's a heavier payload and you want to rotate the part, we can use two movers to lift it and then coordinate the motion between the two movers. The two movers themselves are actually just doing XY motion, but then as you can see, the tooling in the middle is actually doing rotating. So you can get you can get creative with it. A lot of times I get the question, asked, what are the limitations? And truly it's our imagination. What can we think of? How can we, what can we think of doing with this technology? Another little video here, we're demonstrating how you can, like, say, load a silicone wafer into and out of different, different stations. So again, we lift up, we drop down, come back out. So it's an easy way to, transfer a wafer or any other product on a system. Next video here, this is a Stroba. They do inspection systems. So they're utilizing the 360-degree rotation. So now as they bring parts into different inspection stations, this is a show demo that it showed at one of the trade shows in Germany. Well, you can see here, they're doing the 360-degree rotation. So now it simplifies your inspection because you can bring the part in, rotate the part. You don't need another, other devices in that to do the rotation in that. So very simplifies the footprint and gives you a very flexible system. You can take the mover to the next open inspection station, or you can have different inspection stations all on the same machine. As Joe talked about, using the 6 degrees of freedom to replace a Scara robot, you can also think of it as, even a 1 or 2 axis type system. So in this video here, we're actually combining our XTS NCT technology. XTS is our linear transport system. It runs on a rail system. But with NCT, we can do power and data to the movers. So now when you look at it, each mover here is a simple, pick and place robot. And then with the XPlanar, we can either, position the incoming product so that we can pick it up, or we can place a mover how you want to stack it. So in this demo here, we're randomly, mixing up the disk in it, look at it with the vision system, then we go and we pick it, and then on the other side, then we actually place the products, in a fixed format. So it gives you a very compact pick and place system. So you can think of, the bottom side is your in feed, on the back side then would be the product going out. So you would be picking up random product and then spacing it properly in whatever pack out format you want. As far as what's coming, we have 2 new rectangular movers we'll be releasing later this year. We'll have about 155 by 235 millimeter, or 6.1 by 9.25 inches, and then the larger one will be 6.1 and then 9.25. So essentially we're taking our middle side, taking our largest mover, cutting it in half one way or the other to create, these larger type systems. So these 2 movers will be again released later this year. From a software standpoint, we're getting to where we want larger and larger systems. Currently, we can do over 100 tiles per system, and up to about 60-70 movers is where we would max out on a system. But we're in beta right now with the ability to have multi-PC. So you'd have a main controller that would be controlling the system, and then we'll have sub-controllers that would control a set of tiles with the movers. The movers themselves will be able to pass from one system seamlessly from one system. So when you look at it from a top view, it's one large system with a lot of movers, but then under the hood we'll have multiple controllers controlling the system. We're currently in beta with it right now. The I/O programming and test station that we showed at the beginning, there we're actually using this feature right now. We're testing it in beta on it, where we're expanding that out to the second phase of it, so that we've got about 3 or 4 different phases for that whole manufacturing line. And this will be one of the key features that we'll test and make sure that we need for like that system, or customers need for larger systems. We also have the ability to do part handling, or think of it as you can have different grid systems. So in a very large system, like we said, the very first tile is your 0, 0, and X and Y, but then as you get down to like individual stations, a lot of times you might want well, I want to re-reference. I want this to be the 0, 0 point for this section of the machine. And through the part handling feature, that allows you to create, different coordinate or different parts coordinate systems throughout your processes, just to keep it a little bit easier to keep it straight in your head as you're working on it. Joe mentioned starter kits, so we actually have the 2 tile that he showed that they used for their show demo. We have a 2x2, a 2x3, and then this video here is showing a 3x4. You can see the controller box or control panel off to the side. So when you get these systems, they're fully assembled. Basically, you pick them up out of the box, set them down, plug them in, then you can load in your software and you can start doing your proof of concept testing. You don't have to mechanically design the base. You don't have to electrically design a control cabinet. The whole concept here is to make it very easy for you to start doing your R&D or your proof of concept testing. So a summary, key points, again, very modular system, 4 base components, wide range of track layouts, 6 degrees of freedom, X, Y, and Z, tilt A and B, and rotate and C. It's contactless, so it's maximum freedom of movement, no wear, no mechanical moving parts, no vibration, no noise. So when you're looking from a long-term mechanical standpoint, there's no mechanical wear. You're not wearing out conveyor belts. You're not wearing out gears and drives and motors. It's truly a maintenance-free system. Payloads up to 10 pounds or 4.5 kilograms per mover. Again, if you have heavier payloads, you can link movers together. We can use it in high demanding operations. So from a hygienic standpoint, we have the hygienic mover. Then you can also put the stainless over the top. We can do with no mechanical wear. It's good for clean room operations. And we even have, it can operate in a vacuum. So benefits, we minimize machine footprint with the compact design. The pitch list of the variable station and mover pitch is a big advantage. Once you start designing around the fact that you can have different pitches between stations, different station sizes, different layouts, you really end up shrinking the footprint. Typically, a lot of times, we'll see a 30 to 60% footprint reduction over a traditional type system. We have the 2 different tile sizes, so now to make it really cost effective for your project. Increased productivity, again, this individual motion, so we can optimize the throughput of the machine because we don't have to wait while process will be done. As soon as the process is done, we move a mover out, move the next mover in. That mover that's done can be moving to the next station, so it's arriving just in time for to move in as that station's part is being processed. Short time in the market, so clean mechanical concepts. It's very simple. You have a bed with the tiles. You have the tooling for your movers. There's not a lot of, little supporting structure, and the mechanical side is done. And then the simulation, being able to simulate and visualize this is a really big feature that you can do. So, and then the lot size 1, so maximum product flexibility, software-based changeovers now versus mechanical changeovers. So with that, we can open it up for questions. Little teaser here, we'll let this video play. We will be at ProMat next week in Chicago. Our booth is in South Hall, 3823. This is a little video of a demo, interlogistics demo using XPlanar that will be at the show. Essentially from the touch stations, we'll be able to say, okay, enter an order, and then the movers will deliver that order to the pick station. So it's showing how this could be utilized in an interlogistics. So with that, let's go look and see what we have for questions. So first question, let's see here. Oh, can mover cross a gap between tiles? So you can have a gap between the tiles. You can have, like, say, a little millimeter gap between tiles. So with that other tile, you could say, maybe you're lifting it up to another section of the machine, but you can drive across a gap. Obviously, you don't want to be doing a process on that gap because there's the gap there. So it won't be as stable as it would be like in the middle of a tile, but you can drive across gaps. Next question. Says, what is the downtime associated with reconfiguring onboarding tiles for an existing system? It's going to depend. The software can be configured ahead of time. So if you have different like sections of the machine, you're going to move tiles in and out depending upon what you're doing. You can have those configurations done ahead of time, and then it's just a matter of bringing it in, connecting it up to the system so that the controller sees the tiles, and then just pick that configuration, reconfigure. So, you're not talking hours. It's probably going to be the mechanical time to bring the new section in would take more time than it is to fire up the reconfigured system. Let's see. What is the vertical resolution and the repeatability of the z-axis? So from a repeatability standpoint or position accuracy, our position resolution for X, Y, and Z is 1 micrometer. And then the position resolution or feedback is 0.001 degrees for A, B, and C. So a typical repeatability, so you tell a mover, say, go to a position, it will, repeatability, we can get all the way down to 10 micrometer, plus or minus 10 micrometer with the 240 by 240 tiles, and with the new 320 tiles there, we can get down to a plus or minus 5 micrometer repeatability. So as you bring each mover in, we can repeat to it. Now, to get to the 5 micrometer repeatability and 10 micrometer, we can do that, but it also, from a system standpoint, there's a lot of things that come into play for that type of repeatability. Just temperature swings can make your tooling expand or contract more than that. So again, you have to be temperature controlled systems to get it down to those type of repeatabilities, but we can do that. And then from a rotational standpoint, it's 0.03 degrees plus or minus for A, B, and C. So X, Y, and Z have the same repeatability, and then the 3 rotate axis, tilt and the rotate have the same repeatability. Starter kits, yes, starter kits are readily available. We try to keep some in stock, but otherwise, if they're not in stock, the lead times vary, but we can get them quickly for you. On a vacuum operation, so the entire system would have to be in a vacuum. Probably it's a little more than just a quick answer here, but if you want to reach out to us, we can have a more in-depth conversation. But we have done testing, putting a tile in a vacuum chamber and that, so we can dig deeper into the operating, what we would have to do to operate in a vacuum. Will we share the PowerPoint? Yes, we'll share a recording of the PowerPoint. Will be sent out after the meeting. How much side force thrust can withstand? So from when you press on it, it's going to vary. So depends on how much you've got the 6 axes that we're controlling, so we have so much force for it. So the heavier the payload, the more we're working on holding the payload versus resisting you pressing. But typically, probably can press up to like 40, 50 newtons of force on the mover. It's like any other axis that as you push, we're going to fight back on the force, and eventually, you'll either, if we can't get back to the position because you're pushing too hard, we'll either fault on a following air fault, or the I squared T will ramp up, and then we'll shut down from a power standpoint. So it's just like any other servo. You've got your rated power and your peak power. You can go up to the peak power to handle the pressing forces, but then you do have to come back down in the rated current to let things cool down. From a clamping standpoint, we talked about clamping to the surface. What that does is when you drop the mover, we can control the forces and the current. So when you clamp it to the surface, you're basically telling the mover to go negative a little bit, and then we lower the current or limit the currents for the clamping force, because otherwise we'll go to peak force trying to get to a position we can't get to. So we have, concepts there where basically you'll come in, you'll command it to go to the surface and then clamp it or hold it there, but then you're limiting the current so that you stay within the rated power.
Hey, Jeff, could I mention something about that?
Sure.
So well, there were two ways to clamp it, right? One, you could drive it into the table and then let the Z-axis hold it against the table, and you get a little friction helping you. But you can also turn off the Z-axis and just leave the XY on. And we were successful with using like an active. We basically made an active pin, right, where you open up the pin, you put your disc on there. We actually had different size discs, which is why we needed this active pin. So they were different. They went all the way from like 115 to like 135 millimeter discs. And if you pick the right spring and everything, we're using the smallest mover, and we didn't have any problems. We definitely we tried a little bit of experimentation, but overall, like I said, you guys helped out quite a bit with showing me the different software ways I could do it. Took a little bit of experimentation. On those small movers, it wasn't a lot of force though, but it was enough to load a spring, go down to the Z, come back up, and then unload the spring in a controlled manner. If that answers anybody's questions, not sure exactly what their application is.
And thanks, Joe. Yeah, that gives a little more detailed explanation. So a lot of these things, we give a lot of gray answers these days too. A lot of times it's, can we do this? We said, yeah, probably we can. But that's where, Todd's group comes in, our advanced applications group. We do a lot of testing. So we do a lot of proof of concept testing. This is newer technology. We started designing quite a few years ago, but we're still learning as we go too. Every time it's like, yeah, we think we can do that. And it's best to play. So, if you've got concepts or things that you want to do, you can send us tooling. We can, here's what we want to test. We can get things set up so that when you do go to the office, we spend, like Joe said, we spent the day testing your stuff versus, okay, what do you want to test? And then writing the software. We're prepared ahead of time with it.
That's a good point. We actually 3D printed some stuff and tested it, and on a couple of tiles you sent us, and then I actually took the movers and just shipped them to Todd overnight, and he was like, "Yep, it works." Or no, he actually sent me mover dynamics to try that he piloted it on his starter system. So the that testing loop that you guys set up is really great.
Thanks. Couple questions on explosion proof. These aren't like blue terminals. We do have explosion, we have IO and everything for explosion proof applications, but with the XTS and XPlanar, we haven't done any testing or anything as far as being able to put these in you'd have to probably seal it off because there is electronics down underneath that's not, explosion proof design. So with that, I think we've hit all the questions, or we're right on time. So thanks everyone for joining us. We do have another webinar coming up, and I'm sorry I can't remember what the next one is, but I'm sure we'll send out information on what the next webinar series is, unless it's in my PowerPoint. So again, thanks for joining us, and look forward to hearing from you. As you come across applications, just reach out to us. So thanks a lot. See ya.